Welcome to CodeHub India. Our today lecture to host Boot OOT camp for the game Controller on Robotics. Before we delve into the wonders of robots, and you find yourself up to your lab coat lapels in gears, motors, and sensor arrays, it might be a good idea to try and gain some clarity, no small feat, as you'll see, about what a robot actually is and where robots come from. So how does one define robot? Think you know? It's obvious, you say? Tell you what, you go off and do a quick poll among friends, family members, and online chatterbots, while I go fetch a stack of dictionaries. Because one of my other hats is tracking computer and online jargon and slang, I've got lots of dictionaries. Meet me back here in a few minutes. Okay, so what did you find in your survey? I bet, since I've done it before, you probably got responses something like, a machine that can do the work of humans. A humanoid machine that can think and act on its own. A machine that's self-aware. A mechanical man that serves drinks at parties. I can't really define robot, I just know one when I see it. The Japanese Industrial Robot Association, JIRA, is also chiefly concerned with industrial robotics, but it still went so far as to create a whole robot classification system, manually operated manipulators machine slave to a human operator, think Ripley strapped into the robotic exoskeleton loader in the film Aliens. Sequential manipulators devices that perform a series of tasks in the same sequence every time they're activated, a phone switching system. Programmable manipulators, an assembly line robotic arm. Numerically controlled robots, also known as a playback robot, robots that are instructed to perform tasks through the receipt of information on sequences and positions in the form of numerical data. Such robots are typically used for making precision machinery. Sensate robots, robots that incorporate sensor feedback into their circuitry, touch sensors, proximity sensors, vision systems, and so forth. The robots we will construct in Projects 2 and 3 fit into this category. Adaptive robots, robots that can change the way they function in response to their environment. Today's most sophisticated robots fit into this category. Smart robots, robots that are considered to possess artificial intelligence, AI. Whether or not any robots like this yet exist depends on how you choose to define AI, and you think robot is hard to define. Intelligent mechatronic systems, mechatronics, mechanics plus electronics, is a fancy word coined by the Japanese in the 1960s to refer to the intersection of mechanical and electrical engineering and computer control systems. Here it refers to smart devices and embedded systems, such as the highway traffic control robot mentioned in the introduction. Manufacturers are already experimenting with robots. But within the next 10 years, we may start to see them pop up in classrooms, a deputy editor at The Futurist, a trends and forecasting magazine, recently told Business Insider. That's because education is an industry that is especially ripe for change. Schools often struggle with overcrowded classrooms, which means students aren't getting all the attention they need. And Automation Society focuses on reaching future generations beginning at the university level through our student branch chapters and student activities committee. However, there are often inquiries as to how to empower even younger generations with an early look at the robotics and automation field. If you or someone you know is interested in learning more, please see the following suggestions. To become a robotics engineer, the usual approach is to major in one of the related engineering programs at a university. These are electrical and computer engineering, mechanical engineering, and computer science and engineering. To prepare for an engineering major in college, a high school student should take courses in physics, chemistry, and calculus. Students who major in electrical and computer engineering can take basic and elective courses in systems and control, microprocessor-based design, computer programming, image processing, and computer vision, as well as robotics courses. Courses in other majors include mechanical design and control, modeling and simulation, and artificial intelligence. Robotics opens up a plethora of opportunities for both entrepreneurs and students. Industries across a range of sectors such as automotive, atomic energy, defense, space, metals, textiles and manufacturing use robotic technologies very extensively. Robots are required everywhere to improve productivity. They are also being used in operation theaters and rehabilitation centers to augment the quality of life. Developed countries like Japan and America have been using robots to clean rooms, entertain, etc. It is an ever-growing field and many avenues have opened up in recent past. Therefore, students who have the required skill sets will be favored by such industries. The automation industry is a big consumer of robotic technology. Using such technology, the quality of products and processes improve considerably. It is a multidisciplinary engineering field. One gets to understand the integration of mechanical, electrical, electronics as well as computer science disciplines in this field. Depending on the focus area, they can move on to various engineering domains of their choice. Robotics and automation has the potential to revolutionize the industrial scenario. It promises to bring the same result as computer systems have brought in services and other sectors. However, many developing nations like India, Thailand, Indonesia, Philippines are still to adopt robotics and automation in a big way. Considering the gap and opportunity coupled with our experience and understanding of the same, robotics is best suited for industrial automation, manufacturing, packaging, assembly, etc. Most of the tasks in these sectors are dull, dirty, and dangerous for human beings, and as such utilizing robotics and automation in these sectors would improve productivity, safety as well as the quality of the end product. Human operators can then take up more value-added roles in the industry. Who can attend this OOT camp? If you are interested in electronics and especially in building your own toys, games, and gadgets, then this bootcamp K is for you. Although the Arduino is a nice tool for designers and artists, only software developers are able to unleash its full power. So, if you've already developed some software, preferably with C/C++ or Java, then you'll get a lot out of this camp. But there's one more thing: you have to build, try, and modify the projects from exercises. Have fun. Don't worry about making mistakes. The troubleshooting sections and the hands-on experience you'll gain as you become more confident project by project will make it all worthwhile. Reading about electronics without doing the projects yourself isn't even half the battle. And don't be afraid, you really don't need any previous electronics project experience. If you've never written a piece of software before, do not worry, it will help you out. Welcome to the Arduino. About the course content: what we need to do. What exactly is an Arduino? Exploring the Arduino board. Installing the Arduino IDE. Meeting the Arduino IDE. Compiling and uploading programs. Working with LEDs. What if it doesn't work? Exercises. Inside the Arduino, what you need. Managing projects and sketches. Changing preferences. Using serial ports. What if it doesn't work? Exercises. Building a motion sensing game controller. What you need. Wiring up the accelerometer. Bringing your accelerometer to life. Finding and polishing edge values. Building your own game controller. Write and your own game. More projects. What if it doesn't work? Exercises. Thanks for your patience on watching the video.